Good evening, doctor. I am Amir Izzat from Group 5. We present about experiment of effects of different additive on drilling fluids and filter mud cake properties. So this is the experimental background. So drilling fluids or drilling mud are essential component in drilling operation to transport cuttings information, cooling the drill bit and stabilizing the wellbore. To stabilize the wellbore, one of the challenges is to control fluid loss. During filtration, a mud cake forms on the borehole wall, acting as a barrier to prevent further fluid losses. Ideal mud cake is thin yet impermeable to prevent differential sticking. The quality of mud cake is depend on the rheological properties of drilling fluid, which can be controlled using different additives to get an ideal mud cake. Drilling fluid additives such as polymers, starches, and xanthan derivatives are routinely used to adjust viscosity, yield stress, and gel strength so that the fluid can suspend cuttings while providing formation of a thin, low permeability filter cake that limits filtrate invasion. Also, is problem statement of our experiment is to determine the effect of different additives on drilling fluids and filter mud cake properties. So I will pass the next slide to my friend Isdiat.
Next, I will continue. For the adjective, first, we want to analyze the rheological properties of drilling mud with and without additive, which is viscosity, yield point, and jet strength. Second is to investigate the resulting volume of fluid loss from mud cake with different additive during filtration testing. Lastly, to identify the most effective additive between hydroxyethyl cellulose and carboxymethyl cellulose that provide better improvement in market performance. Next, hypothesis. So for the hypothesis, the first one is the drilling fluid with additive will have better rheology properties such as higher viscosity and gel strength than drilling fluids without additive. Second is mud cake thickness from drilling fluid with additive are more thinner than without additive. Third, mud cake from drilling fluid with additive will have lesser volume filtrate than drilling fluid without additive. Lastly is CMC mud cake will have better mud cake performance than SEC hydroxyethyl cellulose. So the scope of study is the experiment scope is limited to water-based drilling fluid prepared under laboratory condition. This experiment focuses on three drilling fluid sample, a base fluid bentonite water to establish a baseline. Second, a polymer modified fluid with CMC. Third, a polymer modified fluid with SEC. Additive concentration will remain constant for CMC and SMC samples. Result will be analyzed and compared to determine which additive provides the best drilling fluid and markets performance.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazdi bin Abu Hashim. So I will continue uh, of our presentation about our theory in this experiment. So this drilling fluid or DMAT is a critically engineered system essential for success and a safety of rotary drilling operation. Its primary function include for transporting drilling cuttings to the surface, controlling formation pressure, cooling and lubricating the drill bit and string. And the last but not least is for stabilizing the wellbore. So to achieve the necessary properties of the function, a variety of chemical additives are incorporated into the base fluid. So these additives are designed to precisely control the fluid's density, rheology, which is the flow properties, and the last is for filtration characteristic. So in our experiment is we're gonna use the additive that function for the fluid loss control agent. For example, we use the CMC and HEC. So the function is this additive reduce the volume of the liquid phase, which is the filtrate, that invade the permeable formation. They work by plugging the microscopic pores in the developing filter cake, making it thinner, tougher, and less permeable. So this is essential to prevent formation damage for the differential sticking where the drill pipe becomes stuck against the wheelbore, and also to maintain the wheelbore stability. So next is about the industry application. So for the CMC, which is the carboxyl methyl cellulose, it is actually an ionic polymer that function as both a viscosphere and also a fluid loss reducer. Second is the HEC, which is the hydroxyethyl cellulose. It's actually an non-ionic polymer known for its efficient fluid loss control and perform in the challenging water chemistry, for example, for the high salinity, and it is prized for forming a high quality and impermeable filter cake. So next we go to the theory about the rheological properties. So the rheological properties of a drilling fluid describe its flow behavior and are critical for hole cleaning, suspension of cutting, and also for the hydraulic calculation. So actually drilling fluid are a non-Newtonian, so their viscosity can change with the apply of shear rate. So these properties are measured using rheometer or we call as viscometer, which apply a non-shear rate and measures the resulting shear stress. So key rheology parameter derived from the viscometer reading. The first one is apparent viscosity. So apparent viscosity is the viscosity of the fluid measured at a single height shear rate. So it represents the fluid's overall resistance to flow. So the formula for the apparent viscosity is the reading from the 600 RPM. So we divide by 2. So we use the unit. The unit is centipoise. So the next is plastic viscosity. Plastic viscosity is the resistance to flow due to the mechanical friction between solid particles in the fluid and the fluid itself. So a high PV often indicate a high solid content. So the formula for the plastic viscosity is the reading from 600 RPM minus with the reading from the 300 RPM. So the unit also in the centipoise. So the third is yield point. Yield point is the component of the fluid's resistance to flow that arise from the electrochemical force between particles. It indicates the fluid's ability to carry cuttings. So the formula is the reading from the 300 RPM we minus with the value we get from the plastic viscosity. So the unit will be in the pound per 100 square feet. So the last but not least is about gel strength. So gel strength is a measure of the fluid's thixotropic property, which is ability to form a gel-like structure when it static. So it is measured after 10 seconds and for 8 minutes. So the unit will be in a pound per 100 feet square feet.
My name is Muhammad Danish Ahmad bin Azrul Nizam. So I will present about methodology. Firstly is the apparatus of the experiment. For apparatus, we use filter press, viscometer, mud balancer, mud mixer, stopwatch, digital weighting scale, and measuring cylinder. So for our materials, we use water, bentonite, hydroxyethyl cellulose, which is HEC, and carboxymethyl cellulose, which is CMC. So this is our flowchart, as you can see here. So this is our procedure. Firstly, we prepare 3 drilling fluid sample as follows. First sample is 25 gram bentonite plus 350 ml water. Second sample is 25 gram bentonite plus 350 ml water plus 1.5 gram CMC. And third sample is 25 gram bentonite, 350 ml water and 1.5 gram HEC. So after that, we measure and record the mud density for each sample using the mud balancer. And then we determine the rheological properties, which is apparent viscosity, plastic viscosity, yield point, and gel strength using the rheometer. And then we perform filtration tests on each drilling fluid sample. And lastly, we record the filtrate volume and measure the mud cake thickness after filtration. As you can see here, this is the schematic diagram for our experiment. Firstly, the compressed air into the pipe, into the drilling fluid, and the drilling fluid being compressed become the filter cake layer and co-sample, and the filtration occur.
Assalamualaikum and good evening to doctor. My name is Tuan Amil Iskandar bin Tuan Muhammad Saiful. I'm here to present the expected result. So this is our table for 3 samples. The data that we are concerned with is viscometer reading, apparent viscosity, plastic viscosity, yield point, gel strength in under 10 seconds and 10 minutes, and mud cake thickness. So this is a table for to evaluate filtrate volume to 3 different samples by time and interval by time, 2 minutes. This is the interval. This is a bar chart to showcase the comparison between the comparison of plastic viscosity, apparent viscosity, and yield point between the different sample. And this is the filtrate volume versus time graph. As you can see, HEC has the lowest filtrate volume against time, followed up by CMC and the base mud. Okay. As per the explanation, HEC is a water soluble. It is more soluble than CMC due to HEC is a non-ionic polymer, which makes it more water soluble. Hence, it is exploited as a thickening agent. And as for base mud, since there is no additive, it has the highest filtrate volume. Our expected conclusion, the results will likely confirm the hypothesis. As a fluid loss addition in bentonite-based drilling fluids, HEC is expected to perform better than CMC. This is due to, as I explained before, HEC acts as a better thickening agent due to its non-ionic characteristic. While as for CMC, is water soluble based additive that is ionic polymer, which make it perform worse than H3 as a thickening agent. Compared to both CMC and this fluid, HEC fluid will provide the least amount of filtrate and create a thinner, more durable and impermeable filter cake, which HEC's superior sealing qualities are responsible for this improved performance. Although CMC is expected to increase viscosity, HEC is far more likely to offer the best filtration control, thus demonstrating its efficiency as a fluid loss enhancer for improving wellbore stability. So these are our references. Thank you from us. That's all for me.